Download this code from codegive.com, link in the description below. OK, let's dive deep into API security with a focus on improper input validation. This is a critical area that's often overlooked, leading to significant vulnerabilities. We'll cover the concepts, threats, common mistakes, and, most importantly, provide code examples in different languages to illustrate how to implement proper input validation. Understanding input validation and why it matters. What is input validation? Input validation is the process of verifying that data provided by a user, or another system calling your API, meets specific criteria before your application processes it. This includes checking the data's type, length, format, range, and content against your expected rules. Why is it essential for API security? APIs are the front door to your application logic and data. If you don't validate inputs, attackers can inject malicious data that can execute arbitrary code. Code injection attacks, example SQL injection, command injection, can allow attackers to run code on your server. Access unauthorized data. Attackers can bypass authentication and authorization checks to read, modify, or delete sensitive information. Denial of service. DOS attackers can send malformed or oversized data that overwhelms your system, making it unavailable to legitimate users. Cross-site scripting, XSS. While primarily a web browser vulnerability, if an API stores unvalidated data that's later displayed on a web page, it can create an XSS vulnerability. Business logic flaws. Attackers can manipulate data in unexpected ways to exploit flaws in your application's logic and achieve unintended outcomes, example manipulating prices, bypassing payment checks. Data corruption. Invalid data can corrupt your database, leading to data loss or application errors. Defense in depth. Input validation is part of a defense in-depth strategy. It's not the only security measure you need, but it's a crucial foundational layer. You should also have strong authentication and authorization. Secure coding practices. Regular security audits and penetration testing. Rate limiting. Web application firewalls, WAFs. 2. Common API input validation vulnerabilities. SQL injection. Occurs when user-supplied input is inserted into a SQL query without proper sanitization or escaping. Attackers can inject malicious SQL code to manipulate the query. Command injection. Similar to SQL injection, but attackers inject shell commands into input that is passed to the operating system. Cross-site scripting, XSS. Attackers inject malicious scripts, usually JavaScript, into input that is then displayed to other users. While more directly a front-end issue, APIs can store and serve the vulnerable data. Path traversal, directory traversal. Attackers manipulate file paths to access files outside the intended directory. Integer overflow/underflow. Occurs when an integer variable exceeds its maximum or minimum value, leading to unexpected behavior. Format string vulnerabilities. Attackers inject format specifiers, example %s, %d, into format strings used in logging or output functions. Buffer overflow. Attackers provide input that exceeds the size of a buffer, overwriting adjacent memory. Improper length validation. Failing to limit the length of input fields can lead to buffer overflows, DOS attacks, or data corruption. Improper type validation. Failing to ensure that input is of the expected type, example expecting an integer but receiving a string, can lead to errors or unexpected behavior. Asterisk lack of range checking. Failing to validate that numeric input falls within an acceptable range, example a quantity cannot be negative. Asterisk insufficient character encoding validation. Failing to properly handle different character encodings, example UTF-8, can lead to injection vulnerabilities. Asterisk missing or incomplete regular expression validation. Using regular expressions for validation but failing to account for all possible malicious input. 3. Input validation best practices. Asterisk whitelist validation, allow list. This is highly recommended. Instead of trying to block all possible bad inputs, a nearly impossible task, define what is allowed and reject everything else. Asterisk blacklist validation, deny list. Avoid this if possible. Blacklists are almost always incomplete and can be easily bypassed. They are useful in addition to a whitelist, but never as the primary validation method. Asterisk validate at the earliest possible point. Asterisk validate input as soon as you receive it, ideally in the API gateway or controller layer. This prevents invalid data from propagating deeper into your application. Asterisk use strong data types. Asterisk use strongly typed languages and data structures to help enforce type constraints. Asterisk canonicalization. Asterisk convert input to a standard, normalized form before validation. This helps prevent bypasses that exploit different representations of the same data, example different ways to represent a URL or a file path. Asterisk sanitization. Asterisk clean or escape input to remove potentially harmful characters. This is often used in conjunction with validation. Asterisk error handling. Asterisk provide clear and informative error messages to the user or calling system when validation fails. Don't expose internal details that could be used to craft attacks. Log validation failures for monitoring and analysis. Asterisk consider context. Asterisk validation rules should be specific to the context in which the input is used. For example, a username validation rule will be different from a product description validation rule. Asterisk regular expressions. Regex use regular expressions for validating complex data formats like email addresses, phone numbers, or URLs. Be careful to craft regex patterns that are efficient and don't suffer from catastrophic backtracking. Asterisk data transformation. Asterisk in some cases, you may need to transform the data after validation. For example, you might want to convert all input to lowercase or trim witty space. 4. Code examples, with explanations. Here are code examples in Python, JavaScript, Node.js, Java, and PHP that illustrate common input validation techniques. I'll focus on a simple API endpoint that creates a new user. The API endpoint expects a JSON payload with username, email, and age fields. Python, using Flask and Marshmallow. Asterisk explanation. Asterisk Flask. Asterisk a simple web framework for building APIs. Asterisk Marshmallow. Asterisk a library for object serialization/deserialization and validation. Asterisk user schema. Asterisk defines the schema for the user data. Asterisk username, string, required, length between 3 and 20 characters, and only allows alphanumeric characters and underscores. Rematch performs a regular expression match. Asterisk email, string, validates that it's a valid email. Asterisk age, integer, required, and validates that it is between 13 and 150. Asterisk schema.load, data, Marshmallow performs validation based on the schema. If validation fails, it raises a validation error. Asterisk error handling, the try, except block catches validation error and returns a 400 status code with the validation errors. It also catches generic exceptions to avoid leaking information to the user and logs them for debugging. JavaScript, Node.js using Express Enjoy. Explanation Express a popular web framework for Node.js. Joy a powerful validation library for JavaScript. User schema defines the validation rules using Joy. Username, string, minimum 3 characters, maximum 20 characters, matches the regular expression $AZAZ0-9 and is required. Email, string, must be a valid email format, and is required. Age, number, must be an integer, minimum 13, maximum 150, and is required. User schema.validate, req body, validates the request body against the schema. Returns an error object if validation fails. Error handling, if there's an error, it returns a 400 status code with the validation error messages. Java, using Spring Boot and Bean validation. Explanation Spring Boot a framework for building Java applications quickly. Bean validation, JSR 303 a standard API for validating Java objects using annotations. At validated, enables validation on the controller class. User record, defines the structure of the user object. At not blank, ensures that the string is not null or empty. At size, specifies the minimum and maximum size of the string. At pattern, validates that the string matches the regular expression. At email, validates that the string is a valid email address. At not null, ensures that the value is not null. At min, specifies the minimum value for a number. At max, specifies the maximum value for a number. At valid at request body user, triggers validation of the user object. If validation fails, Spring automatically throws a method argument not valid exception. You would typically use a at controller advice to handle this exception and return a more user-friendly error response. PHP, using Symfony and the validator component. Explanation Symfony validator component a powerful validation library in PHP. Assert \**, constraints used to define validation rules. Not blank, ensures that the value is not blank. Length, specifies the minimum and maximum length of the string. Regex, validates that the string matches the regular expression. Email, validates that the string is a valid email address. Type, validates that the value is of the specified type. Range, specifies the minimum and maximum value for a number. Validation create validator, creates a validator instance. $validator validate, $user, $constraints, validates the data against the constraints. Returns a constraint violation list object containing any violations. Error handling, if there are violations, it iterates through them and creates an array of error messages. It then returns a 400 status code with the error messages. Advanced techniques. Custom validation rules. All the libraries shown above allow you to define custom validation rules to enforce more complex business logic. External validation services. Consider using external services for validation, such as address validation, phone number validation, or credit card validation. Input sanitization libraries. Libraries like OWASP Java Encoder, DOM Purify, JavaScript, An HTML purifier, PHP, can help sanitize input to prevent XSS and other vulnerabilities. 6. Key takeaways. Asterisk input validation is not optional, it's a fundamental security requirement for all APIs. Asterisk use a whitelist approach whenever possible. Asterisk validate early and often. Asterisk use well-established validation libraries that provide robust and reliable validation capabilities. Asterisk handle errors gracefully and provide informative error messages to the user, while avoiding exposing internal details. Asterisk stay up to date on the latest security vulnerabilities and best practices. By implementing these practices, you can significantly reduce the risk of input validation vulnerabilities in your APIs and improve the overall security of your applications. Remember that security is an ongoing process, and you should regularly review and update your validation rules as your applications evolve.